Welcome and hello. This is a video tutorial in MODSIM, and in this lesson, we're going to be talking about demand nodes. This is part 3, where I'll be covering different node types, specifically the consumptive demand node and the flow-through demand node. All right, so let's get started. What I have on the screen here is a very simple network schematic. We have inflow, followed by demand, followed by another inflow node, or I'm calling it inflow, but they're non-storage nodes, and then finally a sink. So the direction of the arrows represent the links and the direction of the flow. We're going to pick on this demand right here, this purple square. So I'm going to double click and open up the properties window for that demand. By the way, if you haven't already seen parts 1 and 2, those are going to be lessons 9 and 10 in this playlist. I'll go ahead and link them in the description of this video. All right, so we have our demand node properties box opened up here. If I click on the general tab, what we're going to be talking about in this lesson is the two different demand node types. So we have consumptive and we have flow through. If I select consumptive, I have this tab for groundwater data. And then if I select flow through, I have a tab for flow through data. So we'll be talking about both of those in this lesson. Let's start with consumptive. So if I click on consumptive, that's the solid purple square icon, which is currently selected. As described in the previous two demand videos for demand nodes, we talk about some of the details on this general tab and the time series tab, or whichever demand definition type. So we're just going to focus on the groundwater tab or the flow through tab. The groundwater tab here is only for consumptive demands. This tab is used to specify infiltration of surface water contributing to the groundwater, with the possibility that that water will return as surface water, possibly at multiple downstream locations. And also there's pumping available on this tab as well, which we're going to actually look at pumping first. But before that, the user's manual right here on page 69 has a figure that demonstrates the three different processes. Actually, there's 5 processes here, 3 of which we're going to tackle very briefly in this lesson. So there's pumping over here to the far left, which is going to add water to the network. There's stream depletion, where water is going to leave the network. See the arrow flowing away. And then finally, infiltration right here. This is another mechanism for water to be added to our network, our stream network. Also on this image is channel loss. That is handled in the links, and then reservoir seepage. That's also handled elsewhere, specifically in reservoir nodes. Okay. All right. If I scroll down a couple of pages to page 71, what we have here is a model schematic with a artificial node and artificial links. So if we happen to have a demand node I, process of infiltration and then return flow is shown right here, where the infiltration has a path to the groundwater and then back to a downstream or multiple downstream nodes. So something like this is what happens in the background during the stream depletion process. Okay, let's go ahead and get started. The numbers that I have saved in this model is constant values, constant inflow of 100 acre feet per month, constant demand of 10 acre feet per month, and then no inflow or demands anywhere else in the system. So if I go ahead and just look at the results, because I've already ran this, we see 90 acre feet per month, and it's a constant for the entire year. So the values are going to be 100, 90, and 90. But say, for instance, we have some pumping at this demand node to augment the supply of water in our network. So I'm going to open up my properties window, just double click on that demand node, and then click on the groundwater tab. Let's go ahead and add just a constant 5 acre feet per month of pumping. So that should increase the flow to 95 acre feet per month for all these two downstream links. Let's go ahead and click apply and OK. And then let's run the simulation. So that ran. Let's go ahead and check out what our flow is through this downstream link. And boom, now it's a constant 95 instead of what it was before at 90. Next, what I'm going to do is add the stream depletion. So let's go back to that same demand node and then click on the groundwater tab. And then down here, there's a depletion lag table. I'm going to say that all of that 5 acre feet per month that we pumped will be depleted. So I'm going to click on this create table. And then this is where I define the depletion location. So for that, I'm going to select inflow 2. That's the node right here. Okay, here, I'll move this over here. And then what I need to do is specify the fraction of return. So 1 would represent all of the 5 acre feet per month. Let's just go ahead with that. And then for the lag, this is how we specify the time duration. So each time step here represents a time step in our simulation. Now, right now I have a 1 year long simulation with a 1 month time step. So if I put a 1 right here, that means it would all deplete in the same time period. If I put a 1 at the next time step, lag 1, that means it would all deplete in the following time step. What I'm going to do is make it a little bit more interesting. I'm going to say it depletes 25% for the next 4 time steps. So we're going to go ahead and save this, run it, and then I'll show you what that looks like. So I'll click OK and then apply OK. And then let's go up to MODSIM, run MODSIM. Yes, we want to save our changes. Okay, so that ran. Now let's check out the flow through the downstream link. So this is what we're looking at here. After the pumping, we have the same 95 acre feet per month, but then you see that the stream depletion takes it down 1 acre foot per month each month. And thinking about this, it should have been 90, but it says 91 right here. And the reason why that is because of rounding. So what you want to do, and you need to be careful about this, is to specify a higher precision. So I think I have integer precision, MODSIM network settings, and then for my precision value, it says 1 or 0, which means integer, but I'm going to say 2. It means the calculations will carry out to 2 decimal places. I'm going to click apply. Okay. I'm going to save my model and then go ahead and run it. Here's the yes, I want to run. Okay. So that ran. Now, the only change I made was increasing the precision of my calculations. And boom, now we're down to 90, whereas before it was 91. So I'm convinced that these are the actual values. Due to stream depletion, instead of 95 acre feet per month, over the course of the next few months, we're back down to 90. Now, if I had not set it to 1, so say for instance on groundwater, if I set this fraction to less than 1, let me go ahead and edit the table now. If I had set it to say 0.6, 0.6 of 5 is 3. So that means we're going to deplete from 95 down 3 to 92 over the course of those same 4 months, or I guess 5 months. I'll click OK and then apply and OK. So let's go ahead and save and then run and take a look now. All right, so let's take a look at the flow through that downstream. Again, we start at 95, but we end at 92 because I changed it from 100% of 5 acre foot per month down to 60%, which is only a depletion of 3 acre feet per month. Oops, I'm zooming in here. All right, the last part of the groundwater tab that I want to demonstrate is groundwater infiltration. So let's open up the properties for that demand node once again. Click on groundwater. Here's the box for groundwater infiltration. It's a similar interface and controls as depletion, except now we're going to be adding water to our system. So the return location I'll set to inflow to, and then the return fraction, this is going to be, I'm kind of making something up here. I'll just say 0.4. And then for the lags, let's set it to 1/3 for the next 3 months. Okay, that looks good. And then down here, we also need to specify the infiltration fraction. This is 1 minus the efficiency. So basically, the portion of the water delivered that infiltrates to groundwater. So the numbers would range between 0 and 1. 0 is no infiltration, and then 1 would be 100%. So let's just go ahead and set it to 0.2, just making something up here, and then apply and OK. Now, before, with our last run, we saw the flow in this link deplete from 95 down to 92. With some infiltration I just added, it will go from 95 down to something between 95 and 92. It won't go all the way down to 92 because remember, we're adding that infiltration. Okay, so let's go ahead and run the model. Okay, that ran. Let's check out what the plot looks like. And here we have from 95 down to what looks like about 92.8. And you can see that in this first month, we have seepage, but we're adding some infiltration, seepage, but we're adding some infiltration, seepage, but we're adding some infiltration. And then this last month here is the largest drop because we have seepage only. We don't have any infiltration contributing to this fourth month. All right, well, that's all I had as an introduction for the consumptive demand, specifically talking about the groundwater tab. We went really quick through it, and there's lots of other details and complications we could have added. But what I want to do in the rest of this lesson is to click on General and then talk about the flow through demand node type. So when we select flow through demand, we now have this flow through tab. This is when the flow demand is to have flow going through a specific link, but for that water to not be consumed. So instead of setting a minimum flow in the link, which you may be tempted to do, so here is the link, here is the cost, right here's the minimum flow. If you set this something higher to 0, this is a hard constraint and could very easily cause your model to fail due to infeasibility. So I would recommend leaving this at 0 and then using some flow through demands as soft constraints, which can be violated but with a penalty. So let's go back and switch this again from General tab, Flow Through, click on the Flow Through tab. The user's manual on page 52 has this diagram right here where we've got node 1 is a reservoir, node 2 is the flow through demand, and node 3 is a downstream non-storage node. Now, the flow can get from node 2 to node 3 in two different ways. First, there's the solid line, which you physically draw onto the map. And then the second way is through this demand, or flow through demand, which is going to have a negative cost, but it's also going to have a maximum value that's based on what that demand is. Since this cost will be negative, then the water will want to flow through the artificial node and artificial links first. So it leaves through this node 2 to our artificial demand D, and then it re-enters at a downstream node like 3 right here. So if there happens to be excess flow, then the excess flow is called a bypass credit link. That's this flow right here, Q23, in each time period T, where this L right here represents the iteration number. So this is, again, is an iterative process to determine what the actual flow through node is. And the default is that for that demanded flow through node flow to be returned unlagged in the same time period. Let's go ahead and take a look at our actual model here. So we have a bypass credit link. We're going to set that to this link right here from demand to inflow. So let's go ahead and set that. Boom. And then for the flow through nodes, that's going to be set to inflow 1. So let's go ahead and set that to inflow 1, our non-storage node downstream. And then the flow through fraction right here is going to be set to 1. If we happen to have multiple downstream nodes that the flow through demand serves, then we would just list them in this column right here. I don't have any others, so let's just zero that out. But the flow through fractions right here in the second column would have to sum to 1. So that's how that works. I'll click apply and then click OK. Now you can see the icon has changed to a flow through node. I can go ahead and rename it to whatever I want. And then just the final thoughts. The fractional distribution associated with the flow through node, which is what we're seeing here, because we can subdivide that flow into multiple flow through nodes. This is advantageous because it allows the user to divide the flow according to predetermined fractional distribution rather than demand priorities. And also it allows for extra flexibility when calibrating the model. All right, well, that's all I had for this lesson. What we talked about were the two different types of demand nodes. We talked about the flow-through node, which has a flow-through tab, and then the consumptive demand node, which has the groundwater tab, which involves pumping, seepage, and infiltration.